Thank you for attending this session on Agent Drift. And in this session, we are going to talk about how to monitor and manage the performance of AI agents in production, what techniques we use, and what kind of best practices we have. A quick introduction about myself. I work as a principal ML engineer in Cisco's customer experience team. I'm driving AI/ML across multiple use cases in CX. And I'm also an author on LinkedIn Learning on GenAI courses and also other courses on the ML field. So what is that we're going to cover? We're going to look at what agent drift is and how is it different from the classical ML drift. We'll be looking at techniques to measure agent drift, some implementation results, and also best practices for managing drift. So this is a quick background on the use case that we'll be talking about. So this is in Cisco's customer experience team. And this team is a big team of about 20,000 people all over the world. And it is going through, and we are going through an agentic revolution. And there is a strategic push towards using agentic AI everywhere. And we have so far built 100+ agents and deployed and in various stages of deployment and in production. And literally every workflow that we have been building has been impacted by it. And there are several use cases across the board with adoptions, renewals, tag, testing and validation, etc., that we use agents for. And the deployed agents, of course, are having a lot of traction. And in terms of the challenges that we face, of course, there is a scaling challenge. There is a collaboration challenge because simply everybody is building agents. Their engineers or not doesn't matter. 20,000 people building agents means there's a lot of duplicates that are being built. So trying to collaborate, trying to standardize things across, trying to reuse, all of that is challenges. And of course, performance management is a challenge, which is what we are going to talk about in this session. And this is where agent drift comes in. We have classical ML drift. I'm sure many of you are aware of classical ML drift, which is where the predictive accuracy of a model drifts and decays over time, which is you build a model and then you test it for accuracy, you evaluate it, you're happy with it, you go and deploy on day 0, and then periodically you monitor the performance over time. And some models like the Model 3 or the green line stays up on the same level. Some of them starts drifting suddenly like Model 2, or some of them starts drifting slowly like Model 1. So drift happens in many ways in classical ML. There are two types of drift there. The concept drift, where the relationships between the feature and target variables will change over time. This is a problem with how the model has built the relationships. Or sometimes it's a data drift, which is the incoming data distributions have changed over time. This is already there. And our challenge in Cisco, when we are using building agents, is how can we take these concepts and apply them for AI agents? Are they still one and the same, or are there more challenges, more kind of things to look at? And what we learned from that and the lessons learned is what I'm going to be talking about in this session. Let's shift to what is AI agent drift. So agent drift, it is essentially you have an AI agent deployed in production, and its performance may drift and decay over time. You haven't changed any of your agent code, but still this drift may happen. And how do you first measure drift? To measure drift, you have to measure something like a metric. And you need some kind of an overall business metric through which you measure the performance of an agent. Like you can have something like successful renewals rate, or a self-service rate, or even something like task success rate. It could be technical, it could be business, but you need a metric first to measure the success of an agent. And what formula you use, there are many kind of approaches there too. And then once you have performance, then you're trying to measure the performance for different time intervals, weekly, daily, monthly. And then you compare the performance of your agent over time. And when you do this comparison is what you measure drift for. Drift is when this performance changes over time. And in agent or drift also, it is kind of the same principle we use. But in agents, what we found was there are multiple external variables that impact the performance of the agent, and we are going to be talking in detail about those variables and how to measure them. And each variable's performance and drift needs to be measured. It's not just your overall performance of your agent, but we got to measure each of these variables, their performance, and also their drift, and then use it to see what's going on with the agent, to root cause why an overall agent might be differing. And individual variable drifts can actually explain the overall drift of an agent. So let's look at what are these various variables. Before that, let's look at what metrics we used for agent performance. Of course, you can choose metrics based on what kind of observability systems you have, but we used what is called agency. I'm not sure if you guys have heard about it. This is an open source framework from Cisco. This has its own metrics computation engine, and as a part of that, we measure a lot of metrics as a part of it, and that's what we use for our CX agents. And we use the metrics that comes out of it. There's some links are here that we can use to go look at the metrics and their descriptions. And these metrics are across the board. They could be agent level, session level, system level, call level. Different levels of metrics are available. And you could actually use any or many of these metrics to measure agent drift. And which metrics you choose is usually based on your use case. With this, let's move to what are the variables in agent drift. So we have the agent. And when I say agent, we're talking about the code for the agent, which has all the workflows, it also the instructions and stuff like that. And to measure the overall performance of an agent, you measure the task success rate or any other business metric you want. And based on that, you measure the overall agent drift. So you measure task success rate over time and then see if that drifts, and that is your overall agent drift. Now, what are the variables that comes in when you're measuring for an agent? The first one is the input goal. The goal that the user provides to the agent. During evaluation, we would be using our own evaluation data set. It has a set of goals, and it has its own characteristics, and you measure with that. But that can change when you go to production. How users use your system, what kind of task do they use for, all of that can skew over time. And you want to first measure them with some metrics. And that comes what we call as goal drift. So goal drift occurs for various kinds of metrics. So one metric could be topic distribution. What kind of topics or tasks is your agent used for? Another one could be the length of your input goals. And some of them, users could be very verbose in giving input. Some of them will be very small. You might have tested your agents with a given size, and then users are using it in a different way. Third is complexity. You might have built your agent asking one task for every request. Some users may be giving 2 tasks, 3 tasks in one single request. We don't know. So what kind of complexity comes in for the goal? That's also something we want to measure between evaluation and production, and in production for different time intervals. The second variable is context. Again, context comes from outside. And context is a huge challenge because more often than not, you're not using a static data source for your agent. The data source you're using is dynamically changing. For example, you're using a Jira system and getting Jira tickets and sending to your LLM. How people post into the Jira ticket system itself can change over time. And it happened to us, we're taking data from a Jira system, and there was somebody else built another agent that actually now started creating tickets on the Jira system. And when it created tickets, how it logged tickets drastically changed. What kind of information it put into the tickets drastically changed. So the context that comes into the system also changed. And that can start having impact on how your agent is performing. So here again, we think we are looking at the same metrics like topic distribution, length, and complexity. We have not gone in depth into context, so we still don't have good results on it. That's something we are planning to do. The third aspect is the model itself. We are using a model for many reasons: reasoning, planning, generation, reflection, and the model's performance can change over time. Usually we have seen the model's performance won't change if you haven't changed the model itself. But if your model is evolving, you're trying to do 1 point increment on your model, things can change drastically. And here too, we want to start measuring different metrics like intent recognition accuracy, groundedness, completeness. There are a lot more metrics like that you can use to measure the performance of the model. We also call this reasoning drift. And you could include metrics that makes more sense for your use case. The fourth one is tools and agents. Tools and agents are some things on which you perform actions. You could also get context from there. The way we differentiate between context and tools and agents is context is more about the content. Tools and agents, we're looking at the plumbing. Like, am I calling the right tool? Am I putting the right parameters to the right tool? Am I getting the right kind of inputs in the right kind of format and stuff like that? And here we have a number of metrics, like we call it collaboration drift across tools and agents. So we could have something like workforce cohesion index that measures how well your agents work with each other. Tool utilization accuracy is the LLM picking the right tool. Tool API call precision is the LLM picking the right parameters to the tool. Again, these you can argue that they are more model related, reasoning related than collaboration related. Yeah, that's okay. But as long as you measure them, that's very important. So these are kind of some of the metrics that we measure across the agents that we use. Then what do? Once we have these metrics being measured, remember that these metrics are measured for every goal. If when a given day you have 1,000 goals coming in, we have 1,000 such metrics measured for each of them. And we need a way to aggregate them for every day so that you can then compare day by day or month by month. So how do we aggregate it? So we have the first technique we use as called distributions, and this is very similar to what we do in classical ML. So in this case, we have a renewals agent. It has different types of goals, and you can see that different goals get utilized for different days differently, and some of them they may skew significantly. And if your agent is not resilient to these changes, its performance can also degrade over time. So how do we do distributions? As metrics are computed for every goal or task. We convert to distributions for each interval. For each interval, we create a distribution. And even if it is like a continuous values, like length, we can convert them into range-based histograms. You can also do that. So we use this for things like types, length, complexity scores, etc. And after that, you can get these distributions for different time intervals and compare them using statistical tests like chi-square test and KS test. These are pretty popular in the classical ML world. And these usually give you out a p-value. And that p-value is what we would say the drift is. So if a p-value is less than the significance threshold, this is usually how you compare p-values, which is typically less than 0.05. If it is less than so, we say that there is significant drift occurred and we need to take some action. So this is coming from the classical ML world itself. The second way we do drift measurement is again using aggregate values and slope. In this example, we have tool utilization accuracy. So these are values from 0 to 1 and 1 being the highest. So how do we measure them, right? So we again compute these metrics for every goal and task. And we have to find an aggregate value for an interval, the simplest one being what is the mean for a given day. Of course, it's kind of too much generalization, we know, and we are trying to see how we can improve upon that. And you have to pick at least 3 intervals, like 3 days, and then plot them in a graph like the blue line you see here. And then you can fit a line over it. And then you get a linear line you can fit over it. And then you find the slope of the line. And this is, again, classic mathematics that you use to get this. And this slope represents the drift. So the bigger the slope means there is more drift. And this slope can be positive or negative. So if it goes positive, it means you're getting a boost in performance, which is okay. If it goes negative, then that means a drop in performance happens. So both are okay. So if that drift is negative, and again less than a threshold, then it is considered significant. So this is the second technique we have used. And we talked about thresholds for drift, right? When do you know that a significant drift has occurred? And this is a very tricky thing to get to, because this threshold specifies when you have to take action, because there will always be drift happening. Slight drifts will keep happening. It will keep going up and down, up and down. But when do you take action? So the right threshold value, what is it? It is based on, number one, the metric you used, and second, it is also based on the use case. This is pretty tedious. We're trying to see if we can arrive at some kind of a common recommendation. It has so far been pretty hard. For example, minus 0.05 is a good starting point for p-values. We kind of know that. But then for slope, we still don't have a good number. And again, we have to do a lot more experimentation for your use case to keep finding the right value. Because if this value, we set the threshold too high, we won't catch a real drift. If we set it too low, then we would be having a lot of false alarms. So this is the kind of the theory behind what we are trying to build and what kind of results did we get. So we're going to see one of our agents called the renewals agent. And this is kind of the drift metrics we observed for, this is I think for production data, this drift over 3 days. We got about 1K plus samples a day. You see that there is an overall drift that is the goal success rate. We use a threshold check like slope less than minus 0.01. The value observed is minus 0.06, and no, there is no drift there. But then you see in the breakdowns or the fine-grained drift measurement, we see two of them, like the goal length, we see there is a drift, and there is workforce cohesion index, we see there is a drift. And when we see a drift, then it means that we have to take action, go explore more about what's going on, and then what is the root cause, and try to go fix it. So what we have seen is that when you see overall drift, this is across many agents. So when you see an overall drift happening, usually there is also a drift happening in one of the finer grained metrics. So you see that there is a drift happening in one of the other drifts that indicates that why the overall drift is happening. On the other hand, when you see a drift in the lower level metrics, there may not be a drift in the overall one. And the reason could be that even though the external factors are changing, your agent is resilient to that. And that's how the agent improves over time. So your agent becomes more and more resilient to what is happening in the outside world, and then you keep fixing things around your agent, your design, and your instruction, so that your agent becomes resilient to what is coming from the outside world. And we have not added context drift yet. That's still a work in progress. We only see goal, reasoning, and collaboration drift. So this is results for one agent, and now we are kind of measuring this for other agents too. Now, what are the root causes observed for drift? When we looked at what are the popular use causes of why we saw drift, right? The first thing is the mismatch between goal characteristics between evaluation and production usage. This is classic, where your evaluation data set does not match your production data set. It again happens here. There's no surprises there. And the next thing is more interesting, where there are silent changes to software running behind tool interfaces. So we are using a tool, an MCP kind of interface, that is front-ending some other application or a system or a database. Now, there are changes happening in that system which you are not aware of, right? Unless your development teams have very good communication to say, how that you communicate with each other. Typically, that communication happens when your agents are directly talking to each other. But if the agents are instead using what is called shared memory, like some agent writes to like a database, you're reading from the database. That kind of thing, typically that collaboration doesn't happen because you assume the database is there and you start from there. But there changes in behavior. You start logging verbose stuff. You started logging more attributes. You change the meaning of the attribute and stuff like that. That can impact you. So the silent changes happening outside your agent can impact you. Model upgrades changes, again, no surprises. Even if it is minor changes, sometimes they do introduce drift. Instruction changes, this is a given. Sometimes this keeps happening, like I found one bug and I'm going to fix it by adding one small instruction, an additional sentence in my instruction. And should we bypass the evaluation? No, it can cause drift too, because it can change how your model behaves. And frequently changing data sources. That happens all the time in enterprises. The data source from which you're getting context, they keep frequently add, mod, delete, all things are happening, and that can also change how your model, your agent behaves. And incorrect threshold choices, that happens when you have false alarms. That's another cause we found for drifts. Initially we set it to be too low, and then we started screaming, okay, things are not okay. And from this, what are kind of the best practices we have developed and we have observed and learned? First, of course, this everybody knows, evaluations are a must. So here is an interesting thing. I'm sure you would have also been facing it in your companies, that as long as it's an ML team that is building agents, ML teams typically follow a rigor, right? They always go through the evaluation process and stuff like that. With agents today, everybody in engineering is building one. In fact, everybody outside of engineering is building one. Everybody in field is building one. You then add, GitHub Copilot, all vibe coding and everything. Everybody's building agents. But a lot of them do not know the rigor that is involved in evaluating models, and then how do you certify them for production. So this kind of a process is a must. We have another talk yesterday about continuous collaboration and continuous development, and that is very important to have continuous calibration, which is continuous evaluation. Every time some things are up, you do a code change, you need to have calibration running in there. And evaluation data sets should match production data sets. Same thing happens here, no surprises. And this is more important, run evaluations even if the change happens to external integrations. Typically, your CI/CD pipelines are set up so that, only when your code changes, you're going to be running all kinds of tests. When some other system changes, you're not doing that. But here it's better to run evaluations even if you come to know that some other system is changing, you want to test with those systems. Use versioned APIs for tools and agents. This has been pretty scary because you may have we have MCP servers that are shared by many agents. And that MCP server tries to support the functionality needed for other agents too. So they may come and add a new tool or a method in their MCP server listing. The next time your agent comes up, it is going to pull that tool list and start using it. All of a sudden, your tool list grows. And then once that happens, you don't know how well your reasoning is going to work. So it's better to use versioned APIs. MCP is today kind of weak there, but you got to be looking at this and making sure that any additions and changes to your MCP do not impact your system. It's better to use versioned APIs and then stick to that. 6 strict input-output controls. This is something we have seen a lot, which is you call an API, it gives you a JSON, you take the entire JSON and send it to the LLM. But in that JSON, there could be 10 attributes. You only need 4 for your use case. You're sending the rest, right? When you do that kind of a thing, then they add a 11th attribute, and that 11th attribute is a verbose text field. You start sending that also to the LLM, and that can confuse the LLM. So it's better to look at the data you get from external sources, better to prune it to only what you want, and then send it to the LLM. Don't start sending everything like a flush to the LLM. Continuing on this, context engineering is becoming more important. Again, don't send everything that you have to the LLM. Make sure that you prune it, you manage it, and only send what is needed. This is another lesson we are learning over time. Experiment with threshold values. Of course, we try to now have multiple threshold ranges, right? There is an yellow range, orange range, and a red range. So kind of, we take action based on what range has been violated. Users are usually the biggest culprits because they use the system in ways that they're not intended to use. So train your users on how to use this given specific system, especially you are exposing some kind of an open ChatGPT kind of an interface. The other thing we are seeing is that, for example, in CX, right, any query has its own business context. When I say business context, a tech engineer or whoever is going to come and query, they will always query in the context of a given customer and a given product. So if you expect them to include the name of the customer and the name of the product in their free-form input, then that's kind of, hit or miss. So rather we combine both free-form text input as well as some other additional non-free-form stuff, like we'll have a drop-down on customers, go pick your customer, pick the product you want to know about, and then type your question. And then we rewrite the prompts to include those additional values also, make it like a JSON, and then send it to your reasoning model. That makes, that reduces errors in terms of, missing values that is coming from the users. And of course, finally, we want to invest in tracing and tracking tools like Langsmith. We do have Langsmith built in, and through agency, we make sure that every agent is starting to log things. Again, this is a hard discipline, as I said, to enforce, especially when everyone across the world is building agents. So that we have a centralized place we can store, then we can drive our metrics computation over on top of it, and then drive drift computation over on top of it. And this is pretty much what our lessons learned are. I hope this is something that would have interested you, the experience we had. That's pretty much I have. Thank you. We have time for questions. Yes. Sorry? Oh, okay. Okay. Is this okay? Okay.
Is there a time, like length or number of iterations you wait for to start measuring drift, like just for statistical significance and stuff like that?
So typically, for every interval you choose, you need to have enough number of samples. So if I have like 3,000, 4,000 goals I handle every day, then I can do it per day. But if I'm only doing like 5, 10 goals a day, no, that's not enough. I would typically require around 500 to 1,000 samples so that I eliminate the mathematical, what do you call, forgot the term. So that there is consistency in the data. So you determine your intervals based on your volume. It's also about if I have different kinds of characteristics because we also found seasonal variations like, how you use goals. Like the adoptions agent becomes very busy during quarter ends and year ends because that's when people are doing all kinds of, sales stuff. So there is also seasonal variation that you can observe in Drift also. So that is also something you have to accommodate. Yes.
Thank you. Speaking of the seasonal thing, have you tried to incorporate time series for the drift?
Time series is something, so the thing about Drift is that we have looked at it. What we found was that we cannot take too many data points because, after that, if a thing goes like this and falls down, if it allow it to take too many data points, then the slope becomes almost flat. So you want to catch it in 3 or 4. I can't do 2 because that will be too fluctuating. So at 3 or, that's what we're looking at 3 or 4 so that we can catch a drift quickly. Now you may be right because we are ourselves learning about the stuff. And over time we may realize that, it could be better for us to do it more long term also and try. So I'm not claiming that the techniques we use are the best in breed. We ourselves are looking at and learning from what we are doing here. 2.
Thank you.
Any other questions, guys? Okay. Thank you, guys.